on where we're going to start looking at graphing the linear equations in two variables. So our rectangular coordinate system is also known as the xy coordinate plane. Our ordered pairs x comma y tells us where x coordinate, y coordinate is at. The point 0, 0 is called the origin. This is where the x-axis and y-axis intersect. To graph a linear equation, the graph of a linear equation in the form of ax plus by equals c is a straight line. This is known as standard form. And you might want to make a little note that capital A, capital B, and capital C are traditionally integers. Every point on the line is a solution of the equation. Every solution of this equation is a point on the line. How to graph a linear equation? Find 3 points. Technically you only need 2, but 3, your line will be much more accurate. And we'll do those in an organized table, which we'll look at examples of. Plot the points in the rectangular coordinate system. Check that the points line up. If they do not, carefully check your work. Draw the line through the 3 points. Extend the line to fill the grid and put arrows on both ends of the line. X-intercepts and y-intercepts of a line. X-intercept is the point A comma 0. This is a y coordinate of 0, and this will be the x coordinate on the x-axis. Now there is a typo error here. Right here, this should be 0 comma b, so if you could replace with 0 comma b, that's when your x coordinate is 0, and you're going to find where it crosses on the y-axis. Okay, to use the equation of a line, that's going to be this one up here. To find the x and y intercepts, you put 0 in for x. To find the y-intercept, you put 0 in for y to find the x-intercept. And we'll look at examples of that. Next, we also have the slope-intercept form, y equals mx plus b. That's another equation that we're going to look at. So, whoops, come back here. You have your y-intercept at 0b and the slope as the directions, which we'll talk about as we build our tables. Quickly here, other 2 lines, vertical line and horizontal line. These, if it's a vertical line, it will not cross the y-axis. So it's just going to be straight up and down. X is always going to be the same, and you'll notice there's no y in the equation. If it's a horizontal line, then the graph is in the form of y equals b. Again, notice that there's no x in the equation because it will not cross the x-axis. All right. Okay, time to do a little work here, how to graph our points. So if I'm looking at my points here on the graph, A, you start at the origin. I'm going to count along the x-axis. That's the horizontal axis. This is my vertical axis. That's the y-axis. So 1, 2, 3, 4. You count left and right first. Down 1, that point A, capital letter, to represent point A is at 4 for the x-coordinate, -1 for the y. B, 1, 2, 3, -4. I don't go up or down, so it's at -4, 0. Point C, 1, 2, 3 to the right, up 1, so C is at 3, 1. And D is at 1, 2, 3 to the left, 1, 2, 3 down, -3, -3. Excuse me. Plotting the points E, 0. I don't count left or right. We go straight up 4. 1, 2, 3, 4. There's E. -2, 0 is F. -5, -2 is the G. And 2, -3, that's the H. All right. Does these ordered pairs, are they a solution to this equation? So to check this, you're going to put x as -1. Y is -4, and you're going to substitute it into my equation. -4 times -1 is a 4. 4 minus 5 is -1. This is a false statement. Therefore, it is not a solution. For B, x is 5, y is -26. I substitute in just like I did with a -1, -4. I get -20 minus 5 is -25 again. False statement, not a solution. Give 3 points that lie on the line y equals 5x minus 4 by choosing different values of x. What I would always do is use the easiest thing to multiply by first, and that's 0. So if I put 0 in for x, 5 times 0 will cancel out 0. I'm left with -4. So this will be 0, -4 as my point. Next easiest number to multiply is a 1. Then I plug it in. 5 times 1 is 5, minus 4 will give me a 1, and that will be my point 1, 1. And then just go to the next positive number, 2. 5 times 2 is 10, minus 4 is 6. This will be 2, 6. All right, If we do the same thing trying to graph points, we'll do the same thing. Choose x equals 0. That's the easiest. You notice that this canceled out, so that's like covering it up. Y is going to be negative 3, so I'm at 0, negative 3. Let x equal 1. 1 times 1 is 1, minus 3 will be negative 2. And x is 2. 1 times 2 will be 2, minus 3 is negative 1. That's the point 2, negative 1. We'll plot our points. 0, negative 3, 1, negative 2, 2, negative 1. And then draw your line. Again, now we have y equals negative 1/3 x. Again, I'm going to start off with 0, plugging in 0. That will give me a 0. Now here we want to be smart. We don't want to use 1 now because then you got to work with fractions. So ideally you want to cancel this denominator. So now your x's you want to count by 3. So I'm going to put x equals 3. So negative 1/3 times 3. The 3's cancel. That leaves me a negative 1. There's my point at 3, negative 1. Then what I'm going to do is then put a negative 3 in, or you could put a 6. I'm going to go with a negative 3 because then all that does is change the sign of my previous answer when I substituted a negative 3. So we had a negative 1, but now a negative times a negative is a positive. Now it's a positive 1. So I can plot 0, 0. I can plot 3, negative 1. I can plot negative 3, 1. Draw my line. So again, you should recognize anytime you put x equals 0 in for x, the constant is your y-intercept. Here, everything's zeroed out, so I have a 0. All right. Okay, number 7, we're going to find 3 different points. Now in this case, notice my equation is x equals negative 5. There is no y coordinate. So there's no y variable. There will be no crossing of the y-axis. So this is a vertical line. So I can have negative 5, 0, negative 5, negative 3, negative 5, 4, negative 5, 6, negative 5, 1. It doesn't matter. I go to negative 5. I start to plot the points. It makes a vertical line. So because it's vertical, it does not cross the y-axis. There is no y variable in the equation. And when we get to number 8, there's no x in the equation, so this is horizontal. It has to be parallel to the x-axis. So all your y coordinates are going to be 5. 0, 5, 1, 5, 2, 5, 3, 5, negative 2, 5, 1, whatever. Plot those points. It's horizontal. All right, building a table. So if I start with y equals 6x minus 4, again, I'm starting with 0 first because we found that pattern. That's going to cancel out. My y is negative 4, so there's my point 0, negative 4. Now, when x is 1, now 6 times 1 will be 6, minus 4 is a 2. 1, 2 is my point. When x is 2, that's now 6 times 2 is 12, minus 4 is 8. So 2, 8. So if you notice here, my y's are increasing by 6 as my x's increased by 1. So if I'm now going to go backwards, I'm going to decrease by 1, then I want to subtract by 6. So negative 4 minus 6 is negative 10. Negative 10 minus 6 is negative 16. And there's all my points. Well, these points that we can plot a 0, negative 4, and a 1, 2, and that's all we can plot. Draw my line. We'll do the same thing here. Put in a 0, cross that negative 4x. That's negative 2. There's my point. X is a 1. Negative 4 times 1 is negative 4. Minus 2 is now negative 6. So now as we increase by 1, we're subtracting 4. So this will be negative 10. And then in reverse, now as your x subtracts 1, we're going to add 4. So that will be a positive 2. And that will be a positive 6. And then we'll write out our ordered pairs and we can plot our points. So there's 0, negative 2. There's 1, negative 6. We can plot 1, 2, and negative 2, 6, and draw my line. The more points you can plot, the better. Y equals negative 1/2 x. Again, notice that our x's are now counting by 2's because of the denominator. So we put 0 in, we know we're going to get a 0, so we're starting at the origin. I put a 2 in, it's going to cancel the 2 and leave me with a negative 1. And when I put a 4 in, 2 goes into 4 twice, times negative 1 is negative 2. So there's those 2 points. So again, notice as my x is increased by 2, my y's decreased by the -1. So now when I reverse that, x decreases by 2, y will increase by 1. So plus 1, there's my point. Add 1, that's 2. -4, 2 is my point. So I plot my points. They all fit on my graph. I draw my line. So here we have 6y plus 12x equals 36. We can convert it to have y by itself. So we'll do that side work over here. Subtract over the 12x. Divide everybody by 6, and this can be our new equation. So 6 divided by 6 is 1y, -12 divided by 6 is -2, 36 divided by 6 is 6. So I replace it, 0 cancels this out, we're going to have a 6, there's my first point. When I put in a 1, now that's going to be -2 plus 6 is 4. So now again, note, as I increase by 1, my y's will decrease by 2. So this will be my 0.14, this will now be -2, which is going to be 2. As I decrease by 1, now I'm going to be adding by 2. So this will be an 8, make your point. This will be a 10, make your point. So we can plot our points. There's 0, 6, 1, 4, 2, 2. Draw my line. All right, so now we have y equals -2/3 x plus 4. Denominator's 3, so that now tells me I need to count by 3. So 3, 6. And then count backwards by 3. -3, -6. I put in a 0, that cancels out, I get a 4. There's my 0.04. So as I increase by 3, my y's are on the top. That will decrease by 2, so 4 minus 2 will be 2. And there's my 3, 2. Then subtract another 2, puts me at 6, 0. When I subtract 3, now I'm going to need to increase by 2. So this will be a 6, and then an 8. And then I build my points, and I can plot my points. 0, 4, 3, 2, 6, 0, and -3, 6, and I draw my line. 14, let y be Jane's salary in thousands of dollars after she has worked X years at a company. Assume that the equation y equals 3.5x plus 48 describes the relationship between x and y. Complete the table below. By how much does Jane's salary increase each year? All right, so 0, that's my 48. Okay, so here we increase by 1, so now we're going to add 3.5 to 48. That's 51.5. Add another 3.5, that's 55. Add another 3.5, 58.5. Add another 3.5, 62. All right, so by how much does Jane's salary increase each year? 3.5 is what it's increasing by, but that's in thousands of dollars. So we have to multiply 3.5 times 1,000, and that would be 3,500. So that answers this question, and I forgot to put this in here, so just put 3,500 right there. Okay, use the graph to identify the x and y intercepts of the graph. Write the intercepts as points. Note that the x-axis, there's 2 squares to 4, so I'm counting by 2's. So 2, 4, 6, 8, 10, 12, 14. Between 14 and 16 is a 15. That's my x-intercept. Going down, also -15, so 0, -15 for my y-intercept. 16, vertical intercept, that's the same as my y-intercept, so that would be 0 and 1,000. Horizontal, that's your x-intercept, that would be at 50, 0. Alright, 17. Determine the horizontal and vertical intercepts for each graph below. Intercepts must be written as order of pairs. If an intercept does not exist, write DNE. So here, the x-intercept and the y-intercept. Y-intercept, x-intercept, they're both in the same spot, 0, 0. Here we have a horizontal line, so it's not going to cross the x-axis or the horizontal axis. So let's see, we got to figure out what we're counting by here. That's 1, 2, 3, 4, 5 squares to 25, so we're counting by 5s. 5, 10, 15, that's -20. So my y-intercept's at 0, -20, and my x-intercept does not exist. That's a DNE. All right, here, let's see, 1, 2, 3, 4, 5, so we're counting by 2s. 1, 2, this would be a 4, 0, and that's going to be 0, -10 for the vertical intercept or the y-intercept. And as I said, there's 4, 0. All right. 18, find the x and y intercept of the graph 2x plus 4y equals 8. So as we saw back here, your x-intercept always has a 0 for the y-coordinate, and your y-intercepts always have 0 for the x. So we can speed this up and say, okay, my x-intercept is going to be 0. You put that in for y, and then y-intercept is going to be a 0 for the x. We'll put that in for x. So let's make that substitution. So 2x plus, well, this is going to be 0. That cancels out. 2x is equal to 8. Divide by 2. 8 divided by 2 is 4. That 4 goes in as our x-coordinate. So y-intercept, we'll put 0 now in for the x. That's 2 times 0. Well, that's zeroed out. 4y equals 8. And 8 divided by 4 is 2. We'll put that 2 up here. So what's my pattern here? I call this the cover-up. If I want to find my x-intercept, cover up the y term. There's your 2x equals 8, just like we had here. Solve it for x, divide by 2, x equals 4. If you want to find the y-intercept, you cover up the x variable. There's my 4y equals 8, which is right there. Divide by 4, y equals 2, that's where I plot my point. So 19, if we have 5x plus 2y is equal to 20, this is my standard form. Finding our x-intercept, cover up the y term. 5x equals 20, divide by 5, x is equal to 4. Find my y-intercept, cover up the x because that's a 0. 4y equals 20, divide by 4, y is equal to 5. Plot our 2 points, 4, 0, 0, 5, draw your line. Now in 20 here, sometimes you'll see authors use this as their standard form because they like to set it equal to 0. We prefer to have the x and the y on one side of the equation, move the constant over, so we're going to subtract it over, and now find your x-intercept. Cover up the y term. 5x equals negative 10, divide by 5, x equals negative 2, that's negative 2, 0. Find your y-intercept, cover up your x term, negative 10 divided by negative 2 is positive 5. Plot your points, draw your line. And hopefully you start to notice a pattern, and you'll notice that capital A and capital B are dividing evenly into capital C, and we have standard form. All right, 21. Find the intercepts of y equals 4x. Okay, so technically subtract the 4x over, if you will. If I want to find the x-intercept, negative 4x equals 0, x equals 0. Cover up the x term, y equals 0. They're both 0, 0. So here you're going to have to probably let x be a 1 so you can find another point. So 4 times 1 is 4. So the origin and 1, 4. Now I can draw my line. Find our x-intercepts here, our x and y-intercepts. Add over the 1/4 if you wanted to. You can leave it right now, put 0 in for x, and that cancels out. And if you want to add this over, cover up the y to get rid of 1/4. You multiply by its reciprocal. 4 over 1, so x equals negative 4. So negative 4 is 0, and 0, negative 1, draw my line. 23, a company buys a new bulldozer for $124,750. The company depreciates the bulldozer linearly over its useful life of 20 years. Its salvage value at the end of 20 years is $14,750. Depreciation is the decrease or loss in value of the equipment due to age, wear, or I think I cut something off there. All right, so what we have here are 2 points. This is my initial cost. So that's 0 years, and that's my y-coordinate. After 20 years, that's going to be my point 20, and then this is the value, 14,750. So to express the value of the bulldozer V in terms of how old it is, we're going to have to find the rate of depreciation. So this will be my second point. 14,750 minus 124,750, second y minus first y over second x minus first x. So simplifying all this work, we're depreciating at a negative $5,500 per year. So we start with this cost, and then we minus that 5,500 times T. For every year the bulldozer is in use, we subtract its value, its depreciated value. If we wanted to find the value of the bulldozer after 6 years, we put 6 in for T. Let your calculator crunch out the numbers, 91,750. So 124,750 minus 5,500 times 6. 24, the aquarium charges $18 for an adult admission and $9 for a child. The aquarium bill for a school field trip was $468. If we let C represent the number of children tickets and A represent the number of adults attending the field trip, we come up with what we call our value or cost equation. The total cost, $468. If A represents the number of adults, we have to multiply each adult ticket by $18. If C represents the number of children tickets, they all get multiplied by 9. Now, there's my linear equation. It's in standard form. So instead of having X and Y, we're using capital letters. It doesn't matter the variables you use. If 38 children, that's C, plug that in, attended the field trip, how many adults were there? Well, 9 times 38, that's 342. We'll subtract that over to the 468. 18A equals 126. Divide by 18. 126 divided by 18 is 7. Now, what's important to understand here is this has to be a whole number. You can't have like 7.5. You can't have half an adult ticket. Okay? So 7 adults were on the field trip. 25, if we look at the graph here, we're going to interpret the meaning of the ordered pair 150 and 200 in this situation. So 150 is representing the x coordinate, so you just attach the name of the x-axis. 150 candles sold is $200, and then that's the y coordinate. Attach the y-axis name to it. So 158 candles sold will bring a profit of $200. Interpret the meaning of the vertical intercept. That's right here, 0, negative 50. So 0 candles sold means we have a profit of a negative $50. That would be our initial cost for purchasing materials to build these candles. Interpret the horizontal intercept, which is right here, 30, 0. So once you make 30 candles, my profit is at 0. I'm at the break-even point. 26, all right, same kind of deal. The graph shows the amount of water remaining in a play pool. Interpret the meaning of the vertical intercept, which is right here at 0.40. At 0 minutes, there is 40 gallons of water left in the pool. At your horizontal, your x-intercept is at 10.0. At 10 minutes, the pool will have 0 gallons of water. We finally emptied it. Interpret the meaning of 9.4. In 9 minutes, you'll have 4 gallons of water left in the pool. 27, the graph shows Sally's distance from home over a 42-minute time period. Vertical intercept is right here at 21, so 0.21 means at, oops, that should say 0 minutes. So let me do a quick edit here. My fingers must have hit the 1 and the 0 at the same time. That was crazy. So at 0 minutes, Sally is 21 miles from home. Again, using the title of the x and the y axis. Horizontal intercept, let's see, 1, 2, we're counting by 1, so that's 42 minutes. We're 0 miles away from home. Interpret 1613 at 16 minutes. We will be 13 miles from home.